National Electrical Code Article 230.71 addresses the maximum number of disconnects allowed in a service entrance. The basic rule limits the number of service disconnects to a maximum of 6 for each service. These disconnects serve to isolate the entire premises wiring system from the utility power supply. However, there are exceptions to this rule. These exceptions allow for additional devices to be connected without counting towards the maximum number of disconnects. These exceptions often include devices that are necessary for the safe and efficient operation of the electrical system. One such exception involves power monitoring equipment. Power monitoring equipment is designed to measure various parameters of the electrical system. These parameters can include voltage, current, power factor, and energy consumption. The purpose of power monitoring is to provide data that can be used to optimize system performance, identify potential problems, and ensure compliance with regulatory requirements. Transient voltage surge suppressors, or TVSS, are another type of device that is typically exempt from the maximum number of disconnects rule. TVSS devices are designed to protect sensitive electronic equipment from voltage spikes and surges that can damage or destroy them. These surges can be caused by lightning strikes, switching operations, or other disturbances in the power grid. A ground fault protection system is designed to detect and interrupt ground faults, which are unintentional connections between a live conductor and ground. Ground faults can pose a serious safety hazard, as they can cause electric shock or fire. The control circuit of a ground fault protection system is therefore typically exempt from the maximum number of disconnects rule. Power operable service disconnecting means refers to disconnects that can be operated remotely or automatically. These disconnects are often used in large commercial or industrial facilities to allow for remote control of the electrical system. Now let's consider the specific case of an automatic power factor correction capacitor, or AFC, with a built-in circuit breaker that is tapped off the bus of the main. Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the electrical power is being wasted. This wasted power can result in increased energy costs, reduced system capacity, and increased voltage drop. Power factor correction capacitors are designed to improve the power factor of an electrical system. They do this by providing reactive power, which counteracts the inductive reactance of loads such as motors and transformers. By improving the power factor, the overall efficiency of the electrical system is increased. An AFC system automatically adjusts the amount of capacitance that is connected to the system in order to maintain a desired power factor. This is typically done by using a controller that monitors the power factor and switches capacitors in and out of the circuit as needed. The circuit breaker associated with the AFC system serves to protect the capacitors from overcurrents and short circuits. It also provides a means of disconnecting the capacitors from the system for maintenance or troubleshooting purposes. The question is whether the capacitor breaker should be included in the rule concerning the maximum number of disconnects, given that it monitors power when activating contactors to correct the power factor. Given the NEC allowance for power monitoring equipment to be exempt from the maximum number of disconnects rule, the answer is that the capacitor breaker would likely be considered a power monitoring device. The AFC system inherently monitors the power factor of the electrical system. This monitoring is essential for the system to function properly, as it needs to know when to switch capacitors in and out of the circuit. The AFC system's control system monitors the power factor continuously. When the power factor falls below a certain threshold, the controller activates contactors to connect additional capacitors to the system. This increases the amount of reactive power being supplied, which improves the power factor. Conversely, when the power factor rises above a certain threshold, the controller deactivates contactors to disconnect capacitors from the system. This reduces the amount of reactive power being supplied, which prevents the power factor from becoming too high. Since the capacitor breaker is an integral part of the AFC system, and the AFC system is actively monitoring power, the breaker would likely be considered exempt from the maximum number of disconnects rule under NEC 230.71. It is important to consult with a qualified electrical inspector or engineer to confirm this interpretation in your specific situation. Local codes and interpretations may vary, and it is always best to err on the side of caution when dealing with electrical installations. To summarize, NEC 230.71 limits the number of service disconnects to 6. However, there are exceptions for power monitoring equipment, transient voltage surge suppressors, ground fault protection systems, and power operable service disconnecting means. An automatic power factor correction capacitor with a built-in circuit breaker would likely be considered a power monitoring device and therefore exempt from the rule on the maximum number of disconnects.